Hello and welcome. I'm Kate Malash, your host for this episode of the Poultry Podcast Show. Joining us today is our guest, Dr. Wilmer Pacheco, an associate professor and extension specialist at Auburn University in Auburn, Alabama. Dr. Pacheco was born in Honduras, where he obtained his bachelor's in food science and technology at the Pan American School of Agriculture in 2005. Shortly after graduating, he moved to North Carolina, where he began a feed milling manager trainee program with Murphy Brown LLC. After a year in this program, he became the night shift supervisor and was responsible for overseeing production of approximately 10,000 tons of pelleted feed per week. In 2009, he obtained a scholarship in the Department of Poultry Science at North Carolina State University, where he earned his master's degree in poultry science and his doctorate in physiology and nutrition. Upon his graduation in 2014, he joined Auburn University's Department of Poultry Science. His research now centers on the interrelationships between feed milling, nutrition, physiology, and the effects of these relationships on poultry performance. He has authored more than 100 popular press and research articles and has been invited to present lectures in more than 12 countries. Welcome, Dr. Pacheco. How are you doing today?
Thank you, Kate. It's good being with you today.
Yes, we're very excited to have you on the show. Before we jump into our topics for today, can you tell us a little bit more about your background and what led you to be interested in feed manufacturing, feed milling, and its interactions with physiology?
Well, I feel like my professional career has been by accident. I will call it that way.
It's
Like
funny
you
how that
say,
happens.
yeah, like you said during the introduction, I'm from a really, really rural area in Honduras. And the only opportunity or the first opportunity that I obtained to move to the city to San Pedro Sula was moving to a technical college. It's a college that was created by the German government in Honduras, and then there you learn about like how to do preventive and corrective maintenance. So that's when I left, my city, Las Vegas, and then when I was finishing the high school, I obtained a scholarship to study agriculture in Zamorano in Honduras. And I remember that one of my brother was like really mad with me because he said, "Well, why do you want to go to agriculture after you are in a technical college?" So I just told him that I was, ready to take that challenge. Zamorano is the best agricultural university in Latin America, and so I moved to Zamorano, and then in Zamorano, my specialization was food science and milk processing. And then at the end of the 4 year in Zamorano, Smithfield Foods offered me the opportunity to come to the U.S. and work in a feed mill. And this is the nice thing about life, like the all the knowledge that I got during the high school served me really well in my career in Murphy Brown. So for me, it was really easy to understand the process, but also connect, like the nutritional aspects of feed milling. So basically, it was by accident, and after 3.5 years in Smithfield, I obtained a scholarship for to go to NC State and do my master and my PhD in nutrition and physiology in the Department of Poultry Science.
Wow. It's so funny how so many of us get into this field by accident, but I mean, we have the best people, so it works out great. I think once you start working in the poultry industry, you never want to leave.
That is true. Yeah.
For sure. For sure. Well, can you tell us some recent highlights from your current research? What are some hot topics in feed manufacturing, feed milling right now?
Well, I feel like the hottest topic that we have right now in my program is that we are creating a methodology that we are expecting to publish pretty soon. And the goal of the methodology was to evaluate the particles in the microstructure of the pellets because, the industry, we have been focusing on what is the particle size of corn, for example. And then we know that when we mix that corn with other ingredients, then the particle size after the mixture changes. And then once that we send all that mixed feed to the pellet mill, the particle size inside the pellet also changes. And the industry has been using wet sieving for years, but wet sieving takes a lot of time. So basically, one of my students, Susan Bonilla, she has been working in the methodology for more than 2 years, and what we have been able to observe is like if you start, like with a particle size of the meal at, let's say, 1,000 microns as an average particle size, the pellets are gonna be like around 700 microns. So we can observe like around 300 microns decrease in or 300 microns grinding that occurs in the pellet mill. And I think this is going to be very important because hopefully it can allow the poultry industry to predict better what are the particle size requirements of the birds. Because sometimes, as an industry, we only focus on the microstructure of the pellet. How hard is the pellet? And microstructure is important for feed intake to decrease feed segregation. But we need to remember that once that feed gets into the crop, the pellets get dissolved, and then the microstructure of the pellet get exposed, and that's what is more important. From the crop on, that's what affects gizzard development. That's what affects reverse peristalsis and nutrient digestibility in general.
Hmm. That is fascinating and obviously very relevant. I hadn't really thought about it that way, but perhaps this explains why taking particle size measurements on MASH never really seemed to correlate in the field to me with what we ended up seeing, coming out of the pellet mill or ending up in the feed pans. It was always so incredibly complex to define all of those interactions. I love that you guys are going to a deeper level with this.
Yes, yes.
Very cool. So, do you think that will have ramifications on the recommendations for broilers for particle size at different stages of life? Or have you looked at the physiological and performance impacts of these different microstructures yet? Or is that kind of upcoming?
Yeah, we have done some research, and we maybe like 2 years ago we did some research evaluating like three different feed forms, and using mash 3 millimeter pellets and 4 millimeter pellets, and then with different particle sizes. We use 750, 1150, and 1550. And Dr. Jessica Starkey was helping us, with the necropsy, and she was really impressed to see that when we were feeding birds with a 3 millimeter dye and then 750 microns, we had proventriculitis in all the birds that we were. So yeah, you can already see that if you start like with a small particle size and then you use a smaller pellet dye, then you are gonna have finer particles in that microstructure of the pellet, and then you won't see. I mean, the gizzard is not gonna be too small, but then what becomes big is the proventriculus, and so you can see just like a tube. You cannot see a good separation between gizzard and the proventriculus, which I always tell the industry that we need to respect these organs because they have different function. I mean, the proventriculus is important for pepsinogen and hydrochloric production. That's what is going to start the protein digestion. So when the peptides enters the small intestine, then the proteases from the pancreas can do a better job, breaking down those amino acids. So we have been doing some of that research, but at the end, the goal will be maybe like this. This takes time, but maybe 5 years from now, we can create like a prediction equation that could tell you, okay, if the particle size of the meal is this is what you are gonna get inside the pellet. And I think that would be helpful for the poultry industry.
That would be amazing, incredibly beneficial, especially because, every mill is a little bit different. So, factoring in things, I would imagine like, what specs you have on your hammer mill, what size pellet mill are you working with, what size mixer are you working with, is probably, and type of mixer would probably impact all those things. So, yes, it's a much more complicated system than it looks like on its face. So you mentioned, various um, particle size target numbers. And I wanted to talk to you about those because I frequently see people use a single number as a reference target, such as we're targeting, 800 microns. But what they really mean is they're targeting a geometric mean diameter of 800 microns, which is just a descriptive statistic from the distribution of the particle size. Can you talk a little bit about the pros and cons of having a single number target and whether people should be doing anything to take variability into account or any practical experience you have on how different particle distributions can impact what you end up with as an end result.
Yeah. Well, I feel like when you think about nutrition, you think about like you don't feed the same level of lysine, right, to the birds in the starter, grower, and finisher. But in the poultry industry, we still choose a particle size, and then that's what we feed throughout the grow out periods. What our research tell us is that as the birds get older, we should increase the geometric particle size. However, like you are mentioning, geometric, I think we need to look also the distribution of the particles. And based on my research, what I typically do, Kate, is like I try to keep at least 45% of the particles above the SIP number 16, which has an opening of 1,990 microns. So the idea is like have enough coarse particles about that sieve, and those are going to be the particles that are going to stimulate gizzard development and reverse peristalsis, because maybe you can have a lot of particles over 2,000 and then a lot of particles over or less than 400 microns, and then your average is gonna be 800. So the idea here is to have a good particle distribution. Sometimes with hammer mills, sometimes can be more difficult because with hammer mills you're gonna have a lot of big particles and small ones. But now I think the majority of the industry is moving to BFDs in hammer mills to slow down the tip speed. That way you can get a more uniform particle size. But I feel like the industry has the opportunity to move those targets. And like what I typically advise is that you should just go and look the birds, and do necropsies at the field, or just check gizzard and proventriculus development in the processing plant if you can. And if you don't have the logistics in a feed mill to have different particle sizes, one idea that I have been proposing is that you got broiler corn, and then you also produce breeders. So one of the things that I'm proposing is like if you don't have a good gizzard development, you can force a percentage of the breeder corn into a broiler diet, and you don't have to start with 10%. You can start with 3% in the starter, then go to 5% in the grower, 7% in the finisher. That way you don't need multiple beans. And the other thing is like when you make these changes, then you should start monitoring 7-day body weight, because if you go too coarse, then that's going to be one of the disadvantages. The birds is just going to take longer to grind the feed in the gizzard, and then that's going to decrease feed intake and body weight. So 7-day body weight might be a good alternative when you make these changes, or something that you need to monitor in the field.
That's great information. It's definitely a balance. I think we have a lot of good evidence that those coarser corn particles are extremely important physiologically for the digestive health of the bird. However, often when it's brought up to have an inclusion of a coarser corn, there are questions raised about the impact on pellet durability. Could you talk a little bit about that, and how do people strike that balance?
Well, like what I ask always is like, I ask, do you sell chickens or do you sell feed? And so basically, if we are selling chickens, we need to focus on pellet quality, right? But there are different factors that affect pellet quality. So we sometimes, the feed mills don't have a lot of control on feed formulation, but they have control on conditioning temperature. And when we have coarser particles, these particles are going to take longer to hydrate in the conditioner. So we need to find alternatives to increase retention time. Maybe adjusting the paddles in the conditioner. We can increase conditioning temperature. The majority of or all research that we have done here in Auburn shows that as you increase conditioning temperature, you improve pellet quality. But there is a point. You don't want to go over 190, because you don't get a big improvement in pellet quality when you go over 190 Fahrenheit degrees, but then you can start damaging enzymes, you can start damaging vitamins, etc. So just keep that balance. And then Also, we can control pellet quality by controlling the amount of fat that we add in the mixer. And the other part that we always forget, and I laugh, when I think about this, but when we think on coolers, we always think on cooling, but they are also dryers. So it's good to take samples after the cooler and also analyze the moisture level of the pellets, because that can tell you if you can make changes on the depth of the pellets in the cooler, or you can make changes in airflow. Sometimes these are changes that are easy to make in the computer, but you need to know that information. How are your pellets dry enough? Because if you are not removing that moisture, then you are diluting the nutritional content of the feed, and then that's going to have a negative effect on feed conversion in the field. So the idea here, Kate, is focus on the other factors that affect pellet quality, control those ones without compromising the microstructure, the microstructure of the pellet.
That's good advice. So you mentioned measurements like that moisture differential in the cooler. Are there any other measurements that you think we aren't looking at as routinely as maybe we should?
Well, like the moisture, we should check. The other thing is, like the coolers always have like temperature sensors at the exits. It is important to keep controlling what is the temperature that the pellets are leaving the cooler. And even, I mean, sometimes the operators don't have enough time to keep looking so many parameters. I mean, you have been in these feed mills, and there is a lot going on. So a good way will be to put alarms. So you can put maximum set points, and then if the temperature of the pellets goes above that set point, the same system can tell the operator that there is an issue there. Because like sometimes um, the systems, when they are working, they are just checking that the motors are running. And let's say if the motor in the cooler is running, but the fan is not running, then you are gonna get pellets that are hot and moist. And if the operator doesn't pay attention to that temperature, then that can create an issue. The other part that is important from the cooling perspective, particularly during the winter time, is to have a good isolation of the duct system, and also to make sure that you got enough or good air speed through the duct, because that air that is leaving, the cooler, has a lot of moisture and has a lot of micro particles in it. So if that air cools down before it leaves the facility, then you can. I have been in some feed mills that they have some mud, particularly during the winter, and that can be due to poor isolation of the dogs or not enough air speed in the dogs during the winter time.
It's good advice for sure. So we've seen in the industry a lot of consolidation and movement towards these mega mill type new feed mills where it's extremely high volume out of one feed mill. I was wondering, because you're running research out of a pilot mill, an exceptionally nice pilot mill at Auburn University there, how do you make your research applicable to these gigantic feed mills? Do you work in partnership with the industry to try and replicate what you're looking at in research outside of the university? Could you just talk a little bit about how your program achieves this balance between doing things on a micro scale versus doing things on a mega scale?
Yeah, so what I have done is like when we think about our feed mill in Auburn, we have very similar equipment that the industry uses. So a good way to replicate the research that we do here is having a feed mill that is representative of what the industry has. The other thing is that sometimes I have the opportunities to go to feed mills and do like a small research. So like um, I can go to a feed mill and then start changing conditioning temperature or trying to change retention time in the conditioner, and then we obtain very similar results to what we obtain here in Auburn University. It's like I think the industry has done a really good job with these research feed mills, like the one that we have in Auburn, Kansas State, or NC State, that we can pretty much replicate. The main differences that we see is that in a research feed mill, the compression ratio in the pellet die is smaller than what the big feed mills do. Like, for example, our LD ratio in our feed mill, in the pellet die in our feed mill is 9, but when you go to the industry, you're gonna see like thicker dies, maybe like with a compression ratio of 11 to 12.
Interesting. Well, I'm glad that everything is, replicating well in the field versus in the university pilot mill. That's always very reassuring to see. Absolutely. So, one pet peeve that I have on the particle size and in process quality assurance side that I wanted to ask you about is for sure in university studies, you're using whatever the standard method is for measuring particle size. You pick a method that's published and you stick with it. What I've noticed is that in the field, like you mentioned, everyone in the mill is incredibly busy. The feed mill quality assurance folks are trying to keep a lot of plates spinning in the air. Occasionally, shortcuts are taken with methodology. Are they losing some of the benefits of using a full methodology by shortening the time or shortening the number of sieves used on a particle size analysis, or does it not really matter as long as they're consistent mill to mill?
Well, it matters a lot because let's say when we do the research in the university, we use a methodology that is the standard methodology, right? And we say, well, this will be the optimum. If you change the methodology, you can get a completely different result. And so whatever we are telling, that the optimum, if the optimum for me is, let's say 900 microns, depending on the methodology that you're using, you might be getting 700 or 1,000. So the main differences that I see in the industry with particle size is that we don't use in some feed mills we don't use all the sieve stacks. So instead of using 12, we only use 6. And this, the main issue there is that when the feed mill orders the sieve, they get like full height, which is 2 inches, instead of half height, which is 1 inch. So when you use those 6 sieves, the risk that you have is that a lot of material is going to stay in only one sieve because you are distributing the 100 grams in 6 instead of 12. So once that one sieve gets full, then you might have particles on top that are small enough to go through the sieve, but they don't have a space, so they stay. So you sometimes can overestimate the particle size that you are actually providing to the birds. So also, I think it's important to mention that companies are doing efforts to evaluate particle size using NIR. I'm sure that you are aware. I think that that's gonna be a tool that we are gonna be able to use in the industry to have real-time information regarding the particle size that we are obtaining from our grinding equipment.
That is a good point.
Yeah, my advice, you know, for the industry in general is like, let's try to use the same methodology so we are in the same pace. And also, even when I see particle size doesn't change a lot. If you do it once a week, and if it takes you 10 extra minutes, it's worth it.
I appreciate you saying that. I was certainly leading the witness with that question there, but I appreciate you reiterating that the full method really gets you the full amount of information that you need.
Yes, yes.
Very cool. You mostly focus on corn particle size. Do you think there's value in measuring the particle size of other ingredients, both from a physiological standpoint for the bird as well as from a pellet quality standpoint?
Yeah, like we we typically focus on corn. Soybean meal, there is some interest on the particle size of soybean meal. What I have observed is that if you grind soybean meal, you can improve pellet quality by 10 to 15%, but then you lose a few points in feed conversion in the field. So um, I think it's worth it also to focus on the particle size of limestone because the particle size is going to change if you are feeding broilers versus if you are feeding breeders or layers. So that's another one that we need to pay attention to.
That's a good point. Switching gears a little bit away from particle size, but still in feed milling, have you seen any good recent work on the impact of feed milling on salmonella control? Often the feed mills are kind of called upon to help with efforts to reduce, the salmonella load or to protect the birds from external sources of salmonella. Would you be willing to speak a little bit about that?
Yeah, we did a project a few years ago, and we didn't use Salmonella. We used Enterococcus faecium, which is a surrogate microorganism. And based on that research, what we observe is that if you can get to 85 Celsius degrees, you can deactivate 10 to the 6 log of in the surrogate, which could translate to 10 to the 6 log reduction in Salmonella. Like what the industry is doing right now, they are using hyogenizers to extend, the retention time, and then provide that extra insurance for Salmonella control. But what we have observed is that 85 Celsius is enough. And the other part that I have been involved too is like looking the incidence of Salmonella in feed ingredients, and we haven't seen problems with Salmonella in feed ingredients from the feed mills that we have sampled, and we have sampled in Alabama and in other places in the United States. Um, but like when we think in Salmonella, we need to focus on that processing control, but also how we prevent recontamination after the thermal processing. So this is we need to take care of the conditioning temperature and retention time, but also we need to make sure that the coolers are clean, that they are not a source of contamination. Make sure that the air that is entering the cooler is clean. And then the other part that is important is that the boots of the elevators, let's make sure that the boots are clean. The good thing is like the majority of the pellet legs are inside the facility, but it's good to go and check. And if you see like buildup of material in the pellet leg, it's a good practice to remove. Then also you can use some, let's say, some chemical controls. So you can use organic acids. And what you what I typically see is like formic acid, lactic acid, and acetic acid. That's going to be good for bacterial control. And I was talking with a friend in Colombia, and he was telling me that if you are producing, let's say, pet food, because the extrusion can control, the bacterial load, then now you can use propionic acid to control mold growth, and that way you can extend the shelf life of the pet food. So depending on the different feeds that you are producing, then the strategy will be different. One thing that is important here to mention, Kate, is that like the thermal processing can control very well Salmonella, E. coli. However, if we have Clostridia in the feed ingredients, then we are going to have it in the mixed feed, and we are going to have it in the pelleted feed, just because they form spores and then they can survive the thermal processing.
That's a really good point. I think we tend to get tunnel vision a little bit about salmonella and other, food safety organisms, which are, of course, important, but there's also a bird health standpoint as well. Well, I'm looking at our time and it's getting close to wrapping up. At the end of each podcast, we typically ask the guests the same three questions. So I would like to ask you those now. The first is, what is your favorite book or other resource? Could be a website, podcast, popular press, just any favorite resource in the feed manufacturing area.
Well, like Feed Technology is a good book. I like to read that one. And I also like to, even though I don't work a lot with health, but I like to see like the Poultry Health Today. I think they have really good information there.
Yes, timely, for sure. That's a great recommendation. The next question is outside of your field. So this can be anything that you're interested in right now. Can you give a recommendation of any sort of resource, book, podcast, newsletter? And it doesn't have to be at all related to poultry.
Well, like it's funny, but I listen a lot to CNBC Business, and I really love to because you learn about like different trends that are happening around the globe. Some of them are related with agriculture, but sometimes are related with technology. I really like that.
No, that's very helpful, especially thinking about supply chain and commodity markets and just kind of having your ear to the ground on what's going on in the world is a great idea. Good recommendation. And then lastly, I'd like you to think of someone that you would characterize as successful, and that can be by whatever you think of as successful, be it in work, family life, personal life, as a person. You don't have to say who it is, but if you could just talk about what kind of qualities or characteristics do you think make a person successful?
Well, I think the most successful people that I have known are my parents because they didn't have the opportunity to go to the school, but they were able to raise 10 children. Yeah, and all of us we were able to go to the school. So I feel like you can measure the successful based on the successful of the children if you have children. But for me, the successful people is like the people that is happy with what they do. So I really like for me, I feel like I'm successful because I love what I do. And also because you can influence the life of others in a positive way. That's what I think success means.
I absolutely agree. That's a great definition of success. And truly, I mean, if you enjoy what you do, it makes it so much easier and so much more fun. So thank you for sharing that.
Yeah, I always think that I could only have a better job and it will be a soccer player, but I'm too old for that.
Yes, we all have that dream job out there. Well, thank you so much for coming on the Poultry Podcast show today, Dr. Pacheco. We really appreciate it, and we hope to speak with you again sometime soon.
Thank you, Kate.
Hope you have a great rest of the day.